Hello, AP Calculus. This is 3.4. This is the chain rule. You're going to love it. All right, here's what I got. Pretend for a moment, before you look at any of this calculus stuff, let's pretend that f of x is equal to x squared and g of x is equal to x plus 3. All right, and if I asked you back in pre-calculus days, what is f of g of x? Well, remember that means you're going to take this whole function and input it into the input value for this f function. All right, so what that means is this whole thing goes into this x. Okay, so how does this relate? Well, we're going to take things like this and find the derivative of them. Okay, so when you see items that look like this, you're like, well, what's the significance of functions that look like this? Well, one, they're composite functions, and what it means is that you have one item inputted into the other. Okay, now, how do you take the derivative of this? Well, you're going to start with the outside function, which is our f here, and you're going to take the derivative of this guy. Okay, and the derivative of that is 2. Okay, and I would say x, but it's the item that you put in for it, which is in this case, it's x plus 3. Okay, do the first. Okay, because remember a power of 2 now becomes a power of 1. And then you have to take the derivative of the item that you inputted into this function for x. So you take the derivative of that x plus 3, which is 1. Okay, and that is your answer. All right, so we basically take the derivative of the outermost part of the function, and once you do that, you take the innermost piece and take the derivative of that, this being the chain parts of the chain rule. Okay, so let's try this. Here's f of x. I'm going to write f prime of x, and it's very similar to the one I did above. Let's move the 4 out front. Okay, and remember by power rule, if you move the 4 out front, this power of 4 now becomes a 3. Okay, and you must rewrite the item in the inside. Okay, so this part didn't change. Okay, that 3x plus 2 belongs there. Okay. Now what we'll do is we'll do the second piece. This is the chain part. We have to take the derivative of this 3x plus 2. And the derivative of 3x plus 2 is 3. For the 3x, and 2 goes away. Okay, so you're now left with 12 times 3x plus 2 cubed. Cool. All right, next one, j prime of x. Now, I'm going to be honest with you, I don't like radicals. Don't like them. So what I'm going to do is take that innermost piece, write that as a binomial, and make this a fraction. Okay, so that, gosh, root of 5 to the power of 3 will give you a exponent of 3/5. Okay, and now you can treat this like you did the previous one. Okay, so notice I didn't put the prime sign there because I didn't take the derivative yet. I just rewrote it. And let's see, I'm going to use a power rule, so I'm going to move the 3/5 out front. This part here I'm not touching yet because I have to subtract 1 to this. So 3/5 minus 1 is -2/5. Okay, and then you have an inside piece. Okay, that must remain just like it did over here, and just like it did over here. This x plus 3 came from the bottom. Okay, now don't forget the chain part. There's always a chain. And the derivative of 2 is 0, and the derivative of negative x squared is negative 2x. Okay, and you can simplify a little bit. In fact, I'm going to simplify a lot. And the way I'm going to do it is like this. I have 3/5. Let's put a 3 on top. Let's put a 5 on the bottom. And let's see, the negative 2x is still in your numerator. Okay, but this is a negative power. I can put that whole monster on the bottom. All right, so I can do that. Make this exponent now a positive number rather than a negative. And that's why you do that step. Okay. Now you can combine this and get that -6 if you want. Okay. And write your final answer like that. There should be 2. All right, if we're good, let's keep going. You don't always take derivatives of the x's. Sometimes you got y's. Okay, and again, this is the same as 2 over 2y minus 9 squared. Sorry, square root, which is a half power. All right, so quotient rule, if you want, I'll show you another way in just a second, but this is the good time of doing the bottom squared first, because when you take it from the 1/2 power and then you square it, that's a power to a power, and that's just going to leave you with a power of 1, which is just 2y minus 9. Otherwise, let's do this. Low times the derivative of high. I like that, at least for now. Low times the derivative of high. Derivative of 2 is 0. Okay. Minus high times the derivative of low. So be careful on this. This is a chain rule. So high times derivative of low. So the first thing I'm going to do is bring out the half. Okay. Then you have to subtract subtract 1 from that. So 1/2 minus 1 is -1/2. Okay. Times the derivative of the inside, and the derivative of 2y minus 9 is 2. Okay. Take that all in. Okay, again, be careful of all your signs and all the little multiplication pieces. There's a lot to it. Okay. All right, first part is nice. This goes away. And over here, 2 times 1/2 is just 1. And gosh, a negative times all of this will still be a negative. And I still have another 2. And it's this 2y minus 9 to the -1/2. I think that looks good. All right, and the last step is this. And this is going to look awkward, but it can be done. Is this -1/2 has to go to the bottom. Okay, so I'll put this here. And now that becomes a positive power. And I just have a -2 on that. Okay. And the last thing that you want to consider is how do you put these together? Now, let's go up here just for a second, kind of near me. If I said x to the second times x to the third, that's really x to the 5, right? And the reason why you got that is because you add these up. Okay, this is really x to the 2 plus 3. Okay, same idea here. You have 2y minus 9 to the first power. There's no first, but we know that's what it is. To the half. Okay, and so you end up with -2 on top. This 2y minus 9 is on the bottom, and 1 plus 1/2 is 1.5. All right, last one is a stinker, okay, and it has h's here. And what I'm going to do is I'm just going to do the first step. I'm not going to simplify all this stuff out because it'll probably fill a lot of this page. And it's not that it's not important, but really the piece that I want you to know is the calculus part, not that ridiculous algebra part. So let me just set it up with you, and I'll put it in the same color blue here. This is k prime of h. And what I'm going to do is I'm going to do a chain rule, okay? First by moving the power out front and making this a power of 1, rewriting what you see here, 1 minus 2h all over 3 minus h, okay? And then you have to do the derivative again. Now you look at this, you're like, now the derivative of this, does that mean I have to do? It does mean you have to do that. That is a quotient rule. Okay, and I don't want to spend 10 minutes just doing algebra because I know you know how to do it. but just do the bottom piece first, 3 minus h squared. Notice that when you multiply those, you'll get a power of 3 on the bottom now. Okay, and it could be that things cancel out, and that would really reduce, but think about the inside piece, just because we're doing quotient rule within the last couple of days. This is low, 3 minus h, times the derivative of the high. The derivative of the high is -2, minus high times the derivative of the low, which is -1, and I'm kind of out of space here, so I'll just kind of creep it up. Oh, darn it. Here's what I'll do. The subtraction that was out front, I'll change that to 3, an addition sign. It won't let me do it. Here. Oh my gosh. Why did the last step have to do that to me? Okay, there's your times 1. That's negative. And in the end, I told you I was going to stop there. I should have stopped a step before that, but that's just the way things go, okay? You could simplify this top piece, but again, I don't want to spend 80% of our problem doing the algebra piece. If you set up the derivative part, that will be enough, okay? Let me say it again. Work out the derivative part. Don't worry about simplifying the algebra, okay?